the same as fasting. A lot of people talk about autophagy, and my girlfriend talks about water fasting. What is your perspective on the role of fasting, how we should do it, if we should do it, when we should do it, who should do it?
I think it depends on what your goal is. So you mentioned people talk about calorie restriction and really, is the fasting just about the calorie restriction? And I think when it comes to weight loss, losing weight, predominantly, hopefully fat, not muscle, then calorie restriction is the main thing to do here. And intermittent fasting is sort of a tool to get you there. In other words, people that are doing intermittent fasting tend to eat fewer calories. And that's been shown in several studies, even if they aren't counting their calories, because they are limited in the amount of time they're eating. And then they're fasting for a longer period of time, they end up just consuming naturally fewer calories.
Being in a calorie deficit, is that going to put you into the ketogenic state that you get from not fasting?
No, not necessarily. No, it's not. So you can be in a calorie deficit, but it depends, right? So when you're in the fasted state, what's important here is you're activating a bunch of pathways that don't become active when you're in a fed state. And there's a lot of biochemical reactions that sort of dictate all that. But you mentioned autophagy, right? And that's the big one. That's happening only when you're really in a fasted state.
What is it?
There's different types of it. So generally speaking, it's the clearing out of damaged stuff within your cell. So what is damaged stuff? It can be protein aggregates. For example, if we think about in neurons, amyloid beta protein aggregates. So autophagy could play a role in clearing that out.
All the plaques and stuff you get in your brain.
Exactly. But you also get plaques in your cardiovascular system. So autophagy can play a role in clearing that out. But it also can be fragments of DNA. It can be, all sorts of gunk and stuff that just can accumulate inside of your cell. And so you're kind of getting rid of that. Also, it can be even on the level of, let's say, it's the organelle level. So you can actually have your mitochondria. We talked about mitochondria being the major source of energy inside of our cells. Mitochondria are very important for the health of all of our cells, our neurons, our muscle, because they produce energy. But mitochondria also accumulate a lot of damage quite easily because they produce energy and they use oxygen to do that. They make a lot of what's called reactive oxygen species. So these are things that can really react with our DNA, with proteins inside of our cells, with lipids, so the cell membranes. So your mitochondria don't really have a repair system like our DNA does. So we have DNA repair enzymes that can repair damage to our DNA, right? That's where magnesium